Alright, this is the last video for chapter 1, and in this video we'll do something really nice, and we are actually going to not worry about all of this stuff after this page 62. So we're only going to look at things up to here. So all of this stuff that comes after, they're not really important for this study design, but feel free to have a look. However, very unlikely it's going to be important for your SACs or your exam. So this stuff here, however, it is important, and it's something you've done over and over again in statistics from probably year 7. But I'm going to go over it again very quickly and introduce you to some new words and some notations as well. So it's about populations and samples. So population consists of all members, and it's not about all members of a country, which most people, when you hear population in media, that's what it talks about, like population of a country, population of the earth. However, it could be as small as all students in a school. So it's all about the setting. So if we're looking for we're doing a survey about the school and we ask everyone at the school, that's the population of the survey. That's everyone that we could ask for. So it's not always about the population of a country. It doesn't have to be extremely large. It could be a bit smaller as well. But we just want to include everyone that's affected by whatever we're asking for. And sample is within the population. So population is like everyone. That's population. Sample would be like there'll be many samples in many little groups in a population. Some would be like a classroom. Some would be like a house, like all of the red house students. Those are all samples. So it's smaller. It's a subset. So meaning it's just part of the population. And it consists of some members of the population. So that's what a sample is. So it is smaller. Now, obviously, sample, the upside of using a sample rather than a population, it's easier because asking smaller number of people and more cost effective when we collect the data. Population, the upside that it's better, it's more accurate, it's more unbiased. However, it is harder to collect data and it is more costly as well. Now, you do need to know all of these notations. So when it comes to population, we use these sort of notations. So if we find the mean of the population, it's going to be this little thing where it's like a little line and like a U, like, oh no, that's not as good. Little line and like a U like that. And for standard deviation, we're using this sign here. It's like a little dash of a line and an O like that. So if you look at this notation here, you already know you're talking about the population and standard deviation of that population. And if we're talking about the size of the population, so how many people is in the population, we use capital N. And population proportion, which we'll cover in a moment, we use P. Now, for sample, we use this mean that we're sort of used to, X with a line on top. Standard deviation is S, we're used to that as well. And this is how you find it by hand, but you're never really asked to find it by hand. We do it using the CAS, so don't worry too much about that. To notate the size of the sample, we use a small n, the lowercase n, whereas the uppercase N for the population. And for sample proportion, which we'll cover in a moment, we use P with a little hat. So you'll see it sometimes with a hat on top like that, or you'll see it like that. So population proportion or sample proportion is sort of a ratio. As you would imagine, the word proportion is to do with ratio. So we're just looking at how many people in that population or sample has that given attribute that we're looking for, that we're asking for, out of everyone that is in the population. So it's sort of like a probability, if you like. So for example, we have a group of 8 here, and we just want to know what's the proportion of girls are within this group. So we just count the girls. We're making an assumption these are girls. And obviously that's going to be 4 out of 8, so it's half. So that's the proportion of girls within this population. So that's going to be same for sample as well. Like this is a sample because we only took 5 people out of the 8, and we're looking at girls again, so we just count 1, 2, 3. So it's 3 out of 5. That's the proportion of girls within this sample. Now really the key thing here is that we want our sample to be unbiased. That is probably the main takeaway out of this video. And we can do that in a few different ways. The best way obviously is to have a big sample. It would be nice. If not, we want to have a sample chosen at random. So we're just picking random people rather than picking like all girls or all boys, or like someone from all year 12 only, or things like that. So we'll look at this exam question as well together. So here it asks, which of the following statement regarding the relationship between summary statistics, so that's the sample statistics, I don't know if I cover that very well. I did write it here. So you might see sample statistics as summary statistics. And we're looking at population parameters as well. So all of these things that we looked at, like proportion, mean, sample size, all of that. Which of these statements is true? So looking at the first one, it says a biased sample will never have the same summary statistics as population parameters. So when a sample is same as population, that will only happen if we have a really unbiased, really good sample, right? So if we pick the sample really well, you would imagine the smaller number of people will represent the same sort of opinions as the whole population if the sample is chosen really well, which never happens. You can't really have unbiased people as a sample, but ideally that's what we want. So the word never will almost always be untrue. We can have the same if we have an unbiased sample, so this will be false. So it's not never, it's almost never. It's very unlikely, but it's not never. The next one says an unbiased sample, which is what we want, which is a good sample. So unbiased sample will represent the same as what the population is thinking. Will have similar as the population. Yep, that seems very likely. If we have an unbiased sample, well, whatever they're representing will be similar to what the whole population represents as well.